Hi guys, welcome back. We're going to continue looking at a couple of questions to deal with forces and how objects are accelerating and our problem-solving strategy that we're using to solve these problems. Okay, so here's question 2a. A vehicle towing a caravan accelerates at 1.8 meters per second squared in order to overtake a car in front. The vehicle's mass is 2,700 kilograms and the caravan's mass is 2,000 kilograms. The resistive forces on the vehicle are 1,100 newtons and on the caravan 1,500 newtons. With what force must the engine apply, or thrust, to achieve this acceleration? Okay, so let's draw a diagram and set up our positive and negative directions. So here I'll say, here we've got the caravan somehow connected to the vehicle, and let's say that they're accelerating towards the right. Okay, so acceleration is that way. That tells us that the net force must also be in that direction as well. Okay, because whatever the direction the acceleration points in, net force must point in that direction as well because of F equals ma. F is a vector, it's equivalent to something times another vector. Most of the time that those two vectors are going to point in the same direction. Okay, so there's our diagram. We're going to have to label this with some forces now. So let's use another color, green. Okay, so because the net force is pointing in a horizontal direction, we can ignore the vertical forces in this case. Okay, we don't have to worry about them because they're all going to cancel each other out. No forces are being applied at a strange angle of any kind. So, you know, the gravitational force of the caravan should be equal to the normal force on that caravan. They're going to cancel each other out. They have no effect on the the horizontal motion of things. Same thing with the vehicle. Gravitational force will cancel out the normal force. No effect on the horizontal motion whatsoever. So we can ignore all that. The forces that will have some effect on the motion are all the horizontal ones. So we know that the car, this object here, which we'll call C, actually, no, that's confusing. C for caravan, V for vehicle. Bear with me. Okay, so that's the vehicle, that's the caravan, and we're saying that the vehicle must be providing some thrust force. The engine is pushing this car and the caravan towards the right with some force. Okay, we'll call this FTH for the thrust. Okay, now the question specifies that there are some resistive forces acting on the vehicle and the caravan. So the vehicle is experiencing a resistive force of 1,100 newtons, which will signify using this little arrow here, 1100. And the caravan is also experiencing some resistive forces of 1500. Okay. Now, both the vehicle and the caravan are also experiencing tension force via the coupling between them, the tow bar or whatever it is. We actually don't need to worry about that for now, because if I say, yep, that's experiencing a tension that way, the vehicle is also experiencing a tension that way, and those two are equal in magnitude because they're connected by the same thing. So in essence, they're going to cancel each other out later on. We'll leave them there because we'll see how they cancel each other out later on. We don't know what the tension is, so we'll just call it FT. And just remember, tension must be the same anywhere along that connecting piece of material. Right, so that's our situation. Our job is to work out this thrust force. Okay, so now we're ready to start setting up our net force equation. So our net force, because of the way that we've set up our coordinate system, the net force is completely in the horizontal direction. So what we're going to do is we're going to sum up all the forces in the horizontal direction. Okay, so what forces do we have? Well, we've got a positive force, which is the thrust. And that's what we're trying to find. We have another positive force, which is actually this tension here. Okay, and we're looking at this system as a whole. We're treating both objects, because they're connected, we're treating them as one object. So we're analyzing all the forces acting on all the objects in this system. So we can actually go ahead and add that tension force, okay, because it is still a force that's being applied in the positive direction. At the same time though, we've got no other positive forces, so at the same time we're going to start subtracting all the negative forces. And notice that on the vehicle, there is a tension force pointing in the negative direction. So we're going to subtract that tension force, and there you can see those tension forces acting on both the caravan and the vehicle, they cancel each other out. Okay, there it is, and we subtract it immediately afterwards. However, we've also got some resistive forces pointing in the negative direction. We've got this resistive force here acting on the vehicle. So we can subtract 1,100, and we can also subtract this resistive force here, 1,500. Okay, this is the net force on the system, okay, on both the vehicle and the caravan. Now, what do we know the net force is equal to? What's Newton's second law? F net equals ma. Okay, m in this case is the mass of the system, because we've analyzed all the forces acting on the system overall. So the mass of the system, we'll just write as msys. You've just got to remember that's the combined mass of all objects in that system. In this case, it's the caravan and the vehicle. And A would be the acceleration of this system, which we've been told is 1.8. Okay. Now we're ready to start solving. Again, I've left some room here for some reason. I don't think we need that room. So let's just write it down here. So our job is to solve for the thrust. We have one equation with one unknown. Okay, we know the mass of the system. We're told the mass of the vehicle and the caravan. Just add them together. We're told the acceleration is 1.8. We're working out thrust. So it must be that the thrust, the driving force from the engine, is equal to the mass of the system times acceleration plus 1,100 plus 1,500. Okay, the mass of the system is 2,700 plus 2,000. Okay, these two combined, which is 4,700, multiplied by the acceleration of the system is 1.8, plus our resistive forces, and pop that on your calculator, and what you should get is 11,060 newtons. So this engine must be providing 11,060 newtons of force to accelerate both the vehicle and the caravan at 1.8 meters per second squared. Okay, go back, review this part of the video, see how we set everything up. Okay, if you really don't understand, watch it a couple of times. If you still don't understand, seek me out. Okay, part B is what everything's the same, except we've got now what is the magnitude of the tension between the vehicle and the caravan. Okay, so here we analyzed in the first part, we analyzed the system as a whole. Okay, in which case we set up a net force equation with all the horizontal forces acting on all the objects in our system, and then we've made that net force equal to the mass of all the objects in the system multiplied by acceleration. In this part B though, it's actually simpler for us just to focus on one of the objects in the system. Which one is up to you, but it actually turns out that focusing just on the caravan itself will make it a bit easier for us. Okay, so just focusing on the caravan. Focusing on the caravan. Okay, let's draw a diagram of what's going on with the caravan. Okay, again, we're assuming that to the right is positive. All right, what forces are acting on this caravan? Well, if you go back to the original picture, there is a tension force. Okay, remember we're just focusing on the caravan now. Okay, ignore everything else. Just looking at the caravan, there is a tension force. We can't ignore that. Okay, because we're not focusing on what's going on in the car. There's nothing that this tension force can cancel out with if we're just focusing on the caravan. Okay, there's also that resistive force. I'll make that arrow a bit smaller, of 1,500 newtons. Okay. You do, of course, still have the vertical forces, gravity and the normal force acting on the caravan, but they're going to cancel each other out. They've got no effect on the horizontal motion of the caravan. Okay. And just remember that this caravan is accelerating that way. Okay, it's accelerating in the positive direction, which is what we've set up. Okay, that's our goal. Now, our job is to work out the magnitude of this tension. So now we're ready to start writing out a force equation. We've identified all the forces acting on the caravan. We know the acceleration. Okay, we can start writing our net force equation. So the net force is equal to, because acceleration and thus net force is pointing towards the right horizontally, we only look at the horizontal forces. So we sum the horizontal forces again. All right, what's pointing in the positive direction? Tension. Anything else? No. All right, what's pointing in the negative direction? We're going to subtract all that. Well, it's really just the resistive forces, 1,500. Okay, there you go. That's our net force equation. But what do we know the net force is equal to? Mass times acceleration, Newton's second law. What's the mass of this problem that we're looking at here? Well, we're just focusing on the caravan. So M is just the mass of the caravan. It's a little bit different to part A. Okay, so mass of the caravan multiplied by the acceleration of the caravan. Okay, F net equals MA. And now we're ready to solve for the tension. We've basically got this equation here. We know the mass, we know the acceleration. We want to solve for the tension. Let's go ahead and do that. Again, I've left room on another slide after this, but we don't need it. That's equal to the mass of the caravan times A plus 1,500. Mass is 2,000 times acceleration 1.8 plus 1,500, and you get 5,100 newtons. Okay, so in order for the caravan to be accelerating towards the right, it needs to have some force, net force pointing towards the right. The only way that that could happen is if this tension force here was much larger than the resistive forces. Okay, and we've now worked out that the size of this tension force is 5,100 newtons. It is larger than 1,500, so therefore it will experience an acceleration towards the right. Okay, go back, watch the video, try and analyze how we set this thing up. Again, if you don't understand, come seek me out. All right, that's it for now. We're going to answer some more questions in the next video. Okay, see you then.